Okay, let's go ahead and get started. Today we're going to be talking about matrices. So let's go ahead and do our first definition. All right, matrix. Now, if you've ever seen the movie The Matrix, I forget when it came out. I think it was probably 2000 or 2001 or something like that. There's this movie called The Matrix. Well, this has nothing to do with that. Sorry to disappoint. But we're going to be dealing with matrices as they are in the math world. Okay? So a matrix is just a rectangular array of numbers. Separated into rows and columns. Separated by rows and columns. So that's what a matrix is going to be. So let's take a look at one. Here's a good example. Let's say we have the matrix 1, 2, 3, 4. And then we have 5, 6, 7, 8, 9, 10, 11, 12. Okay. So that's the first matrix we're going to look at. Now let's get to another definition. Entry, element. An entry or an element is each number in the matrix. Each number in the matrix. That's going to be called an entry. Okay? So how many entries do we have in this matrix? Well, in this matrix, we have 12 entries. We have 12 entries. Okay? How many rows do we have? Also, how many columns do we have? How many columns do we have? Okay, I'm going to change my color to red. And I'm going to circle all the rows. So this one is the first row. This is the first row. And then this is going to be the second row. This is the second row. And this down here is going to be the third row. The third row. So how many rows does this matrix have? This matrix has 3 rows. 3 rows. Keep in mind that rows are always going to go from left to right. Rows are always going to go from left to right, so they're always going to go across. Okay. How many columns do we have? I'm going to change my color to blue for this one. How many columns do we have? Well, columns are always going to go up and down. So they're going the opposite way that rows are going. Columns are always going to go up and down. So here's the first column. I'll circle the first column. It'll be the one in blue. And now let's circle the second column. The second column is right here. The third column is going to be right here, the 3, 7, and 11. And the fourth and last column is going to be over here, 4, 8, 12. So how many columns are there? There are 4 columns in this matrix. And a matrix can have as many rows and as many columns as it wants. But the lowest number that it can have is 1 row and 1 column. Okay? So that's the difference between rows and columns. Rows are always going to go from left to right. I circled those in red. But the columns are always going to go up and down. And I put those in blue. So the columns always go up and down like this. And the rows are always going to go from left to right like this. And you can count how many rows and how many columns a matrix has. Okay? All right, let's get to our next definition. All right, here's the next definition we're going to talk about. Order. Another way to say this is dimensions. Dimensions. That's another way to say the word order. Okay, the order is however many rows, let's say M, and however many columns it has, let's say N columns, where M and N are just numbers. Okay? So if we know how many rows a matrix has, and we know how many columns a matrix has, we can figure out the dimensions of the matrix, or the order of the matrix. So what's the dimensions of this matrix right here? Well, the row number is always going to come first. And since there's 3 rows, it's going to be a 3 by what? How many columns does it have? It has 4 columns, right? So we call this a 3 by 4. This is a 3 by 4 matrix. Okay? And then the last thing that we want to do is we want to be able to specify which element we're talking about. Okay? So let's give this matrix a name. Everybody likes naming things, but when we name matrices like this, we're always going to use a capital letter. So we're going to call this matrix capital M. Very original, right? But we're going to give this matrix a name. It's going to be called matrix capital M. Okay? Now, let's say I want to specify a certain number in the matrix. So what would, and this will be the last example that we do on this page. What if I wanted to figure out what number is in the second row, but the third column? So what is M23? Well, the first number is always going to be the row number. So 2 is going to be the row that I'm looking at. So I want to look at row number 2. And then the next number that comes is going to be the column number. So the column number always comes after the row number, right? It always goes row by column. So what I'm looking at is I want to look at the second row. That's going to be this row right here. I'll circle it in yellow. So this is the second row. but I'm also looking for the third column. So I'm going to circle the third column also in yellow. That's going to be this column right here. And where do the two yellow circles meet at? They meet right here at 7. So that's going to be my answer. My answer is going to be 7. Okay. Let's try another one like that. What is M14? M14. See if you can figure that one out. For this one, you're looking at the first row and the fourth column. So what number is in the first row but the fourth column? So we need to be looking at the top row. This is the first row, 1, 2, 3, 4. But I'm also going to be looking at the fourth column. Well, that would be the last column. And when I do that, we meet up at 4. So the answer for this one is going to be 4. Okay. Let's do one more like that. See if you can figure out what M31 is. M31. What would that be? M31. Not 31, but 31, right? We always have a row number that comes first. So I'm going to be looking at the third row. That's what that first number tells me to do. Look at the third row. So we're going to be looking at this third row down here, the bottom row. But I'm also going to be looking at the first column. So the second number says, hey, this is going to be the column number. So I'm looking at the first column on the third row. And that's going to be this 9 right here. It's going to be 9. Why is the answer 9? Because it's in the third row, right? But it's also in the first column. And that row and that column meet up at 9. So that's going to be my answer for this one. What number is in the third row, first column? That is going to be 9. Okay? So I'll leave this up there for a little bit so you guys can get it. And then we'll move on to the next topic. So a matrix is really just a box of numbers, right? They're going to be separated into rows and columns. Rows are always going to go from left to right. They go across. And columns are always going to go up and down. They're always going to be vertical. Okay? And a row and a column can have however many elements it wants. In this entire matrix, we have 12 elements. And we can specify the dimensions of any matrix by saying how many rows it has, by how many columns it has. So for example, this matrix that we just talked about, this has 3 rows, but it also has 4 columns. So we call this a 3 by 4. So that's why I wrote 3 times 4 at the bottom. We're not actually going to multiply 3 by 4 to get 12. You can if you want to. But when we write out the dimensions of a matrix, what we want to do is we want to write 3 by 4. Okay? Because the row number is always going to come first when we're talking about matrices. And then the last thing we did was we talked about how we can specify certain elements inside of a matrix. Like, let's say I wanted to know where 11 was. Well, I would have to look in the third row. So I would write M3. And then I would look in the third column. So it would be M33. M33 tells me, look at the third row and look at the third column. So if you know the row number and you know the column number, you can tell me what number is inside the matrix. Now for this example, I only chose the positive whole numbers, but you can put any number that you want inside the matrix. You can put in negative numbers, you can put in zero, you can put in fractions, you can put in irrational numbers, real numbers, complex numbers, any kind of numbers that you want. But they all have to be divided into rows and columns. And that's what makes a matrix a matrix. Okay? All right. Let's get on to the next topic. Okay. So the next thing I wanted to talk about was what is a row matrix? What is a row matrix? Wait a minute, let me write definition. Definition, row matrix. Okay, so a row matrix is any matrix with one row. Any matrix with one row. Any matrix with one row. So let me give you a good example of this. Let's say we just have one row where we have -2, 0, 5, 200. This would be a row matrix. Why is it a row matrix? Because it only has one row, right? So what would the dimensions of this matrix be? We always write row by columns, right? So we know it has one row, but how many columns does it have? It has 1, 2, 3, 4 columns. So this is a 1 by 4. Okay. And sometimes we give matrices names, sometimes we don't. We're not going to give this one a name. We're just going to move on to the next definition. So that's what a row matrix is. So if you know what a row matrix is, do you know the definition for a column matrix? What would a column matrix be? Well, a column matrix is any matrix with one column. Any matrix with one column. So what would a good example of this be? Let's say we have a matrix with one column. And let's say it's 10, 20, 30. And we'll stop there. Okay. So what is the dimensions of this matrix? Also known as the order. Well, you know we're supposed to write the row number first. So how many rows does this matrix have? It has 1, 2, 3. So we know it's going to have 3 rows. Okay. How many columns does this matrix have? It only has one column, right? 10, 20, 30. So we say this matrix is a 3 by 1. We know it's a 3 by 1 because we know it has 3 rows, but it only has one column. And by the way, since it only has one column, we can call it a column matrix. Now, sometimes you'll hear me say the word vector. Vector. And a vector is just another word for a row matrix or a column matrix. So a vector is just a row matrix or a column matrix. So both of these matrices that we just talked about, we can also call them vectors. Vectors. Okay. All right. So now that you know that, let's talk about what a square matrix is. A square matrix. Have you ever seen a square matrix before? If not, you're about to. But let's define it first. What is a square matrix? Well, it's exactly like it implies. It's going to look like a square. Well, what is a square? A square is something where all sides are the same length. So a square matrix is going to be any matrix with the same number as rows as it has columns. Any matrix with the same number of rows and columns. It's going to have the same number of rows and columns. You could also say the number of rows is equal to the number of columns. So often you'll see m equals n, where m is the row number and n is the column number. So let's do a quick example of what a square matrix is. Here's a good one. Let's say 5, -7, 4, 3. This would be a square matrix. So why is it a square matrix? Well, how many rows does it have? It has 2 rows, right? 5, -7, that's my first row. And 4, 3. That's going to be my second row. Okay, so it's got 2 rows. How many columns does it have? It's got 2 columns, right? Let's circle them. 5, 4, that's going to be my first column. And -7, 3, that's going to be my second column. So this is a 2 by 2. That's going to be a 2 by 2. Now we're going to make a 3 by 3. So here's another really good example. Let's do 1, 2, 3, 4, 5, 6, 7, 8, 9. And then close it up. How many rows does this have? Well, this one has 3 rows. How many columns does it have? It has 3 columns, right? So this is a 3 by 3. So the row number is the same exact thing as the column number. That's what makes a square matrix a square matrix, okay? And sometimes we'll even talk about main diagonals. So let me show you what the main diagonal is. And I'll do this in yellow. When you go from the top left all the way down to the bottom right, that's called the main diagonal. So I'm going to start at the top left, and I'm going to circle all the way down to the bottom right. And then the numbers that get circled, that's called the main diagonal. The main diagonal. And this only works with square matrices, right? Because only a square matrix will have that main diagonal. All other matrices, like the 2 up here that we did, this one and this one, these don't have diagonals, since that one only has 1 row and this one only has 1 column. So this only happens with square matrices. And you can keep on going, right? We know we made a 2 by 2, we can make a 3 by 3, we can make a 4 by 4 and a 5 by 5, a 10 by 10. You could even make a 1 by 1. What would that look like? Let's make a 1 by 1. This would be a 1 by 1. Notice how it only has one row, but it also only has one column. So this is a 1 by 1. And because the row number is the same thing as the column number, we can call it a square matrix. So then what would the main diagonal be? The main diagonal would be just 1. How many elements are inside that matrix? Just 1. And that element is 1. So that's what a square matrix is. It's always going to have the same number of rows as it does columns. Okay? Now, let's go ahead and get to some homework questions. And we'll talk more about what you can do with matrices besides writing them out. So I'll leave this up there for a little bit, and then we'll move on to the next slide. Okay. All right. Let's talk about adding, and subtracting. Adding and subtracting. Okay. So did you know you can add two matrices together? Let's try this one from the problem set. We're going to do number 1. Okay. 6, 2, and 1, negative 3. And then close that up. That'll be the first matrix. And it's a square matrix, by the way, right? It's a 2 by 2. And we're going to add this to the next matrix that I'm going to write. So we're going to add these two matrices together. 4, 3, 0, 10. 0, 10. So we're going to add these two matrices together and see what we get. Well, first, notice that they're both 2 by 2s. This one is a 2 by 2, and this one is also a 2 by 2. So that means our answer also has to be a 2 by 2. But let me go ahead and change my color to red. We're going to circle the first row, first column. So we're only going to be circling 6 and 4. Okay. So notice that these two numbers are in the exact same spot in their respective matrices. Well, we're adding them together, so what's 6 plus 4 going to give me? 6 plus 4, that's going to give me 10. So I'm going to put down a 10. Okay? Now let me change my color to blue, and we're going to circle the next number in each matrix. I'm going to circle the 2, and I'm going to circle the 3. Now we're going to add these together. What's 2 plus 3? That's going to give you 5. 5. Okay. Now I'm going to go to green, and I'm going to circle the next number. The 1 and the 0. So let's add these two numbers together. What's 1 plus 0? That's going to give me 1. And now let's circle the last number. Negative 3 and positive 10. If we add those together, you're going to get a positive 7. And we're done. Now we can close this matrix up. So we can add two matrices together. We can also subtract two matrices. So we're going to do number 2 next. See if you can subtract these two matrices. And they're both going to be a column matrix. we're going to have 14, 9. Close that up. Minus 10, 5. See if you can get this one before I get it. Now keep in mind how many rows and columns we're dealing with. Both of these matrices have 2 rows, but they only have 1 column. So this is a 2 by 1, and this is also a 2 by 1. So let's go ahead and circle the first 2 numbers. And I'll do this in red. So the first 2 numbers are 14 and 10. So we're going to subtract those. What's 14 minus 10? That's going to give me 4. Okay. Let's circle the next 2 numbers. 9 and 5. What's 9 minus 5? That's also going to give me 4, right? And now, since we're done with all the numbers, we can draw the brackets to our matrix, and we can close this matrix up. And our answer is 4, 4. And keep in mind, this is also a 2 by 1, since it has 2 rows and only 1 column. Now, you can only add and subtract. You can only add and subtract when the dimensions match. When the dimensions match. You can only add or subtract when the dimensions match. So, for example, we can't do something like this. We can't do 2, 1 plus 2, 3, 6, 5. We can't add 2 matrices like this. You can't do it. And that's because you have this extra column over here that isn't matched over here, right? This is a 2 by 1, while this matrix is a 2 by 2. So the dimensions don't even match, right? And if the dimensions don't match, we can't add these 2 matrices. So we can't do that. All right, so the last thing we're going to learn is scalar multiplication. Scalar multiplication. Scalar multiplication. Let's do number 3. Okay, for this one, I have a 4 on the outside, and then on the inside of this matrix, I have a 2 by 2. And the matrix is 1, 2, 3, 4. And I'm going to close that up. So what would the answer for this be? Well, for this one, did you know that you can multiply an entire matrix by a number? You can. For this example, I'm going to multiply everything on the inside of the matrix by what number is on the outside. So I'm going to multiply every single number in there by 4. I'm going to multiply everything in there by 4. So what's 1 times 4? 1 times 4 is going to give me 4, right? Okay. What's 2 by 4? 2 times 4, that's going to give me 8. Let's move on to the second row. What is 3 times 4? That's going to give me 12. And then lastly, what is 4 times 4? That's going to give me 16. And I'm done. That's scalar multiplication. So what I'm doing is I'm multiplying everything on the inside by whatever number is on the outside. And that's called scalar multiplication. Okay. Now, there's a whole bunch more we can learn about matrices and how to multiply them and how to divide them, but we're going to leave that for another day. But the last thing we're going to learn how to do today is we're going to learn how to do a linear combination. And that's what we're going to talk about on the next slide. Okay. So you can add two matrices together. You can add more than one matrices together, right? If you had three in a row that had the same dimensions, you could add all of them together. You could subtract matrices, and you can also multiply matrices by a scalar on the outside. And yes, the number on the outside is called the scalar. Just FYI, that is called the scalar. And I think I forgot to do my dimensions, but this is a 2 by 2, which you probably already knew. And this is a 2 by 2. So the dimensions don't change when you multiply by a number. Keep that in mind. The only time the dimensions actually can change is if you're multiplying a matrix by another matrix, but we're not going to be talking about that today. Okay, let's do a linear combination. A linear combination. So when we do a linear combination, we're going to multiply first. We're going to multiply first. Multiply first, then add. Multiply first, then add. Let's try number 5 on the problem set. Number 5 says 3 times this 2 by 2, 2, negative 3, 6, 7. Let's close that up. And we're going to add that to 2 times the 2 by 2, 1, 3, 0, 4. And let's close that up. Okay, so how would I do this? Well, when we do a linear combination, we want to multiply first and then add. So let's multiply everything on the inside by what's on the outside. We're going to multiply everything by 3 first. And when I multiply everything by 3, I'm just going to get 6, negative 9, 18, 21. So I multiplied everything by 3 first. Plus, okay. Now over here, I'm going to multiply everything on the inside by what's on the outside. So I need to multiply everything by 2. So I'm going to get 2 times 1 is 2, 2 times 3 is 6, 2 times 0 is 0, and 2 times 4 is 8. And I'll close that up. And now the last thing we have to do is add. So let's add these two matrices together. So we got a 6 plus 2. That's going to give me 8. And then we have a negative 9 plus 6. That's going to give me negative 3. Close that up. And then on the second row, we have 18 plus 0. That's just going to give you 18. And then we have 21 plus 8. That's going to give you 29. And that's it. There's nothing left to do, so that's your answer. 8, negative 3, 18, 29. And all of these are 2 by 2s. So that's really all a linear combination is. You're multiplying first and then you're adding. And sometimes in the middle, instead of a plus sign, you might have a minus sign. So you might have to subtract at the very end. But that's what a linear combination is. So I hope that's pretty easy to understand. Okay. So I think that's all I had to talk about today. So let's talk